So in this next section, what we're going to do is have a look at chemical symbols. So we're going to consider how chemical symbol that we see in the periodic table might be different to a chemical symbol for an isotope. So if we just have a look at chlorine here, chlorine in the periodic table does appear slightly differently to how it might appear for an isotope. So the number in the periodic table at the top for chlorine is 35.5, and the number 35.5 cannot be a mass number. It cannot be a number of protons plus neutrons, and so there must be something different happening in our periodic table. And if we were to look at our definition in our periodic table, we can see that we haven't got mass number at the top. We've got something called relative atomic mass. So let's just consider the chlorines. So in the periodic table, chlorine, it looks like this on the left here. It's like this in the periodic table. It's atomic number 17, it's element number 17, it's got 17 protons, but the number at the top in the periodic table is 35.5. That does not mean it has a mass number of 35.5 and that there are 18.5 neutrons in chlorine. That's just gibberish. That number there is a weighted average of the isotope masses, so the isotopic masses of the different isotopes of chlorine. Now, chlorine actually exists in nature as two different isotopes. We've got chlorine 35, we would call it, and chlorine 37. When we say chlorine, we automatically mean that we are talking about element number 17 protons. So when we say chlorine 35, the 35 is telling us the mass number, and chlorine 37. So there are two isotopes of chlorine. And when we talk about the isotopes, then the number at the top will be the mass number, the number of protons plus neutrons in that element. Okay, so there's a difference between what's in the periodic table and isotopic symbols, and that is really important to remember. So here we go in our notes. Let's have a think. Each isotope has two key numbers. We've got the atomic number, which is at the bottom and tells us number of protons. And we've got the mass number, which is at the top, which is protons plus neutrons. So for example, if we go to the periodic table and we look up sodium, we see that it has an atomic number of 11. Now, one of the isotopes of sodium is sodium-23, and in fact that's the majorly occurring one, so in the periodic table the number is 23.0 because other isotopes just don't exist naturally. So we've got sodium with an atomic number of 11 and a mass number of 23. So if we were to break that down and look at that particular isotope, sodium-23, that's what we call that, it's called sodium-23, isotope of sodium with a mass number 23, we can work out the number of protons. Now the number of protons is the atomic number, and that's the bottom number. This is 11. We can work out the number of neutrons by taking the mass number for this isotope of sodium-23 and subtracting the atomic number to get 12. We can work out the number of electrons in an atom. So we know that atoms are neutral. So protons equals electrons. If it was an ion, it wouldn't be true, that statement. So we just need to be careful. But because it's an atom, it has 11 electrons because it had 11 protons. So now we're saying, well, what about the number of electrons in an ion? There is a little formula you can use. A lot of students don't need this formula, but you could do the atomic number minus the charge, including the sign of that charge. So if we were to say that sodium, we find it in our periodic table, it's element number 11. So the number of electrons if we're going to use our little formula, we could say it would be 11 minus the number and the sign, so the charge was +1, and that's 10 electrons. Now, a lot of you would just know that anyway, that a 1+ ion has lost an electron. And if we were to do this for oxygen, this oxide ion, the number of electrons, remembering that you go to the periodic table to find the atomic number, so there are 8 protons in oxygen, so 8 minus the charge, which is -2, and that is also 10. There are 10 electrons in both of these two. These would be called isoelectronic, they have the same number of electrons, sodium ion and an oxide ion. So positive ions are formed when we lose electrons, and negative ions are formed when we gain, so the ion has more. What I want you to do is have a go at filling this table in. A couple of things to watch out for. You will need your periodic table, but only to find the position of the element and assign its atomic number. So you're going to be using your periodic table to find the atomic number. Everything else in this table you will have to work out. The periodic table does not have the answers to the rest of this information. So I'm going to work through the first one, and then you're going to have a go at filling it in, pause the video. So I'm going to go to my periodic table, I'm going to look up sodium. You find sodium in position 11, it's the 11th element in the periodic table, which means it's atomic number 11. That's the one thing that we're using our periodic table for, so you could fill that column in first if you liked. Given that they're talking about the element sodium-23, we're going to use that information to determine some of the other stuff. So, number of protons is the atomic number. Number of neutrons, so is the mass number minus the atomic number. So 23 take away 11, which is 12. And number of electrons in an atom is equal to number of protons, so that's 11. So remember to watch out for ions, because the electrons and the protons won't match. Remember that these are isotopes, so the mass number is not copying from the periodic table. If you're not given the mass number, you'll be able to work it out from the other information in the table. Pause the video now and see if you can fill in this table. So for iodine, you should have got atomic number 53, so protons is 53, 127 minus 53 is 74, and given that it's an atom, if there's 53 protons, there's 53 electrons. And then for the fluorine, you look it up in the periodic table, it's element number 9, and given that it's element number 9, it has 9 protons. But because we've been told that there's 10 neutrons, we're going 10 add 9 is 19 to get the mass number. And because it's an atom, electrons match protons. So for scandium, you should have got 21, 45, 21, 21. We were adding 21 and 24 to get the 45 for the mass number. Calcium is element number 20, so it has 20 protons. 40 as a mass number minus 20 gives us 20 neutrons, and because it's an atom, we've also got 20 electrons. Mg2+. So magnesium is element number 12. And there are 24 as the mass number, so 24 take away 12 gives us 12 neutrons. To get the number of electrons in the ion, we've got 12 protons, and if it's 2+, it will have 2 fewer electrons because it's got 2+ charge, so there's only 10 electrons. Again, another ion here, so element number 13, 27 take away 13 gives us 14 neutrons, but 3+ means lose 3 electrons, so it would have been 13 as an atom, we've lost 3, it's 10. For our bromide ion, bromine is element number 35. There were 44 neutrons, so 44 add 35 gives me a mass number of 79. And because it's a 1- ion, that means there's one more electron than there are protons, so 36 electrons. And our final example, sulfur or sulfide ion. Sulfur is number 16, 16 protons. 32 take away 16 gives us 16 neutrons. But because it's a 2- ion, there will be 2 more electrons than protons, so it's 18. So there's just one last little thing on this page and this section for you to have a go at, which is to see if you can say how many protons, neutrons and electrons are in different isotopes. So we're just comparing isotopes here. And remember from before we said isotopes have the same number of electrons, they have the same number of protons, but they have different numbers of neutrons. They have the same number of electrons, that's why they have the same chemical properties. So pause the video and see if you can fill in this. All isotopes of iron have 26 protons because it's element number 26 in the periodic table. So that's how they're the same. Because these are atoms, there's no charge, then protons and electrons match, so they all have 26 electrons. And then to work out the neutrons, we've done the mass number that was given to us for the isotope, take away the number of protons, and that's given us the number of neutrons. If you look up iron in the periodic table, you'll see it comes out at 55.8, which is an average of these three, and you might say, well, that's not the average of those three, but it's a weighted average, takes into account the amount of each one.